Snail shell, that's the cochlea, part of the inner ear. And the cochlea is responsible for hearing, where the semicircular canals are responsible for balance. In between the two is the vestibule. We'll go through the model here in just a minute, but we're looking at this part that looks like a snail shell. So looking at it close, this is on low power, and what you're looking at is a section through that snail shell. It's all one big tube that kind of snails around to form the cochlea, but if you cut through it, what you see are different parts of that tube being cut all the way around as it winds around here. This middle part, right up in the middle of the cochlea, is not labeled in your textbook or in your Rust book. Now in your Rust book, it's page 93. Beautiful pictures of it. Another one is set right next to you when you're looking through the slide. But go ahead and write it in. This center part right in the middle here is called the modiolus. It's kind of like the center post, and then the cochlear tubes wrap around that to form that snail shell. So the modiolus is this part right in the middle. There's only two that aren't labeled in this whole thing, and that's one of them. Now again, this is on low power, so what you're seeing is this tube has been wrapped around, and we've cut through so you can see a piece of the tube as it wraps around each time. Each one of these little compartments here is a piece of that tube, and we're going to look at that closer. This is where it contains all the hearing apparatus for you to interpret and create an action potential from those waves of sound. Let's take a look at one of these compartments, like this one right here, close up. Looks like this. So this is cross-section of the cochlear tube. First thing you notice, and this was in the slide upstairs, and I said we'll cover this downstairs, so don't worry about it at the moment. But real good pictures in your textbook. We give you the page numbers for this. It's page 545 in your textbook, labeled beautifully, great pictures. But this whole unit here is part of the cochlea. There are three little chambers within this entire cochlear unit. This chamber at the top, there's one in the middle, and one at the bottom. And you can see the three areas, here, here, and here. The top one is called the scala vestibuli. And I was going to look it up, I forgot to, I'll have to look it up here in a second. I think scala is Italian, I think it means chamber, but I'll go back and double check it for you. It's actually Latin, but it also is Italian, same thing. The term means the same thing. So this is the scala vestibuli. The middle one, like you would expect, is scala media, because it's in the middle. Media means middle. Bottom one is scala tympani. So make sure that you can identify the three different chambers. Doesn't matter, see I can go back to this, which side it's on, because they're mirror image. On this one it'd be scala vestibuli, scala media, scala tympani. So for all of these, it's the same three parts, whichever side of the modiolus it's on. Doesn't matter. So scala vestibuli, scala media, scala tympani. Then there are boundaries between those three chambers. This right here is the vestibular membrane, and it's the boundary between the scala vestibuli and the scala media. So this little membrane right there is the vestibular membrane. And it separates the scala vestibuli from the scala media. This membrane right down here that separates the scala media from the scala tympani is the basilar membrane. So it's right here. And again, it separates the scala media from the scala tympani. This is the basilar membrane. And this is all labeled, page 93 in your Rust book, page 545 in your textbook. Now, the top chamber, scala vestibuli, and the bottom chamber, scala media, are filled with perilymph, which is a fluid. The middle chamber, scala media, is filled with endolymph, which is also a fluid, but they're different viscosities. Their thickness is different. Scala vestibuli and scala tympani have perilymph, which is a different thickness or different viscosity than the endolymph in scala media. And you'll notice But on your paper here, it says scala vestibuli filled with perilymph, scala media filled with endolymph, scala tympani filled with perilymph. That means it's fair game for the practical if it's written on here. So make sure you know what fluid is in each of these three chambers. The top and the bottom are the same, filled with perilymph. The middle is filled with endolymph. The difference is how thick that fluid is. Okay, just a couple more structures here. These kind of stringy-like structures here on the basilar membrane. Here's your basilar membrane right here. These little structures right here, this is called the organ of Corti. Corti is capitalized because Dr. Corti is the one who characterized this. It's also known as the spiral organ. This is where those stereocilia hairs are located that take the vibrations from the fluid and convert them into action potentials. So this is where the hearing part actually takes place. Those receptors, those stereocilia hair receptors, transfer the vibrations from sound waves in this fluid into action potentials right here at the organ of Corti. Sits right on top of the basilar membrane. See this little curly Q membrane right there? Kind of reminds me of the fiddlehead on a fern. You ever seen ferns? They have that little fiddlehead part when it's about to seed. That's called the tectorial membrane. That's this little part right here. Kind of a fiddlehead shape. And that's also important in allowing the organ of Corti to convert those vibrations into an action potential. So we've done all but one now. Let's go back and just review real quickly. For this whole cochlear unit here, you have scala vestibuli. Here's the vestibular membrane. On the other side, that's the scala media. The membrane that separates scala